Okay, now flip-flops, the difference between the flip-flop and the latch is the flip-flops are synchronous. So meaning they are synchronized. Synchronized to what? Synchronized to the input clock. Okay. So now the state of the output will change depending on the clock, right? So let's see the one example here. So I'm gonna open this one. Okay, so we have the clock here. So look at pay attention. We have the clock here, and we have the input D. So this is a D flip-flop. We have the D, as you can see, this is the input. Input is 1 right now. Q is equal to 1. Now, the output will change only when the clock changes. Okay, so if I change, for example, 1 to 0, right? So you can change now the Q is becoming 0. Okay, let me stop it here. Let me stop it here. Okay, let me open my pen tool. So let's see what's happening. Let's analyze this. Okay, look here. So now it's 0, right? So when I change 0, I change it here. Here, as you can see, this is the exact position when I change the input to the 0. But as you can see, the output did not change here, right? Why output did not change? Because the output is synchronized to the clock. So output will change when clock is changed. So clock here starts here. So now at this location, as you can see, the output changing from the 1 to the 0 here, right? So it was 1, but the input changed earlier. Since the output is synchronized to the clock, the output changed later than the actual input. So if we keep running this, so let me, if I keep running this, okay, let me reload this. Okay, now if you look to the output, right? So look at the output here. So what I will do is, I will change the input more rapidly than the actual clock. So and you will see that the output will not change accordingly. So let me just pay attention here. So pay attention below here. Okay. So pay attention to the D here. So this the input D here. Just pay attention here. So now I will change the input very fast. Okay, faster than the clock. Okay. Now let's analyze what's happening here. So let's look at the timing diagram. I hope you can see the timing diagram. So as you can see, okay, so here, for example, let's look at this clock cycle, and within this clock cycle. So in this case, it's activated to the both edges. Okay, so it's activated. It's correlated with the both edges in this case. So what's happening here? Within the one cycle, I changed the input multiple times, right? I changed it multiple times, 1, 0, 1, 0, 4 times. But the output changed only once. Why? Because it's synchronized to the edge of the clock. Okay? So when the edge comes, the output is changing as well, right? So here is changing. But again, as you can see, within the one clock cycle, here I changed the input multiple times. But output changed only once. Okay, so this is what this is the meaning of the synchronized flip-flop or synchronized B-stable multi-vibrator. Okay, so this is the meaning of the flip-flop. So only difference between the flip-flop and the latch, flip-flops have the input for the clock, right? So from the circuit perspective, if you look here, so this is the flip-flop, we have this extra input called clock here. So this is the input called clock. Okay, so this is the input called the clock. Okay, with a latch you don't have this input. With latch you have only inputs like S, R, or for example in case of the D latch you have the single D latch input. Okay, but with the flip-flops now you have the extra input, the clock, and the output will change according to the clock, not according to the how often you change the input value. So these are the different types of the flip-flops. So this is the one that we just demo, D flip-flop, right? So this is a D flip-flop. This one is called the JK flip-flop. Okay. The only difference is for this one and this one. You can see the difference is this bubble here. Okay, so bubble means the when is the output is activated when the clock is high or when the clock is low. Okay, so this is the only difference. So this is D flip-flop. We already covered it, how it works, right? So you have the input D, and then you have the input, this input is clock. So output will change only when the clock is changing. So if D is 0 and clock is high, the output will be 0. If D is 1 and clock is high, output will be equal to 1. So this is very simple truth table for this D flip-flop. Okay, and this is the digital waveform and the correlation between the inputs and the output. So this is the input, for example, in this case, if you look, this is the value, the clock is high, D is 0. Okay, so D is 0, so output Q is 0. But as you can see, for example, after some time, at this point, for example, clock is again 1, but at this particular point when the clock is on the raising, so you can see the D is still 0. So the Q will be equal to 0, not 1. Although after some time D is changing to 1, right? So it's changed to 1. But since the output is synchronized to the clock, now the output will not change anymore for this one clock duration. So for this one clock duration, output will stay same. It will stay 0. Okay? Now at the next clock, clock 3, again when the clock is high, we look at this output. So at this point the D is 1. So the output will be equal to 1. And even though throughout this period, again the D is changing from 1 to 0, but output will not change. Why? Again, the output is synchronized to the input. And this is how you're going to actually create the D flip-flop. All you have to add the one more, the input, which is a clock, right? So you can actually create this logic circuit. You can add the clock here. And we already created the D latch, so this is a D latch. Now instead of the enable, all you have to do, you just remove this enable, and instead of the enable, you just add the clock, like this one. Okay, and now you can see how the output will change. Okay. So this is the explanation. I already explained how it works, but you can go and read this and get the more detailed explanation if you want.